Hello, folks. Welcome to Learn Synthesis with Pure Data, Series 1, Episode 11. In this episode, we'll be completing the entire functionality of our synthesizer, giving it 2 oscillator signal chains, and basically for the 12th episode in this series, it will just be about adding different colored canvases and colorizing some things so that things look a little bit better rather than just being black and white and just outlines as it appears now. But by the end of this lesson, we'll have the fully functional 2 oscillator synthesizer that we wanted, or that I wanted, for this introduction into synthesis. So away we go. Okay, so what I'm going to do now, call up our synthesizer. And I wanted to point out something that I found when I opened it up today, preparing for this tutorial. There was a red error appearing in the PD window. And it said OSC_1_ no such send. Now, whenever you see a message like that saying there's no such send or no such object, usually what that means is you have a receive somewhere that's named differently than a send. And what I noticed remembered was that last time we made sure there was a frequency send here in our oscillator object that is OSC_1_freak_out. This sends the frequency out so that the FM module here can then take that frequency in, do modulation if you set it up to do that or not, as the case may be. And then at the bottom, there's an output for this module that's called FM_1_out. And that gets received right back here. So after the frequency has a chance of being modulated by being sent out here to the FM module, it comes back from the FM module here, where then it's applied to the frequency of the oscillators that generate sound. But one thing that I forgot about was that frequency information when it was named OSC_1_freak, before I added out to the end of it, was going here. And so let me open this. It was going to the filter because the filter also needed to have frequency data to adjust where in relationship to the carrier frequency, meaning the frequency of the note being played, that this slider should allow one to adjust. And that's where it was receiving here. This was originally named OSC_1_freak without the underscore out. So it was receiving nothing. And that's what that error message was saying. I had forgotten that output of the frequency had gone to another module, not just the FM module. So I renamed it OSC_1_freak_out right here, so that way, whatever the frequency of the note being played is, and that does include its pitch bend and everything, it will set so that this slider is adjusting based on that frequency where your cutoff, or since we're using low pass, where your cutoff frequency would actually be. So if this doesn't have the underscore out at the end of it in your batch, you need to change that so that this is actually receiving frequency information. So that's just a little catch up of an error that I didn't notice in the last episode, but have caught now so that we can fix it. Now, the first thing we're going to do is by the end of this episode, we're going to basically have all these 1, 2, 3, 4, 5 modules duplicated in a second row, but they're going to be things in them will be renamed so that they are independent, because you don't want like your sends and receives or table names to be duplicates, because then it doesn't know which one to send them to and it creates problems. So the first thing what we're going to do is, because we're going to have two signal sets, we want to give ourselves a very common synthesis technique, which is the ability to apply detuning to an oscillator so that we can change the tunings of these different oscillators and have them be able to chorus, which means when you have two different oscillators that are at slightly different frequencies or greatly different frequencies, it creates an effect. When they're slightly off from each other, and I'll demonstrate this after we do it, you get a chorusing effect where the frequency, the overall tone just sounds expanded a bit because they're not exactly in tune with one another. When they're off by other amounts, like a semitone or more, then it creates an effect that's really just a harmony. You could have them set apart by a certain amount of steps in a musical scale so that it creates a harmony. So we want those abilities. So what we're going to do is open up the frequency, the OSC_1 module, and we're going to add the ability for this here in this chain. Right here at the top, I'm going to zoom in even a little bit more. This is where we're receiving the MIDI note. So this is what we're going to actually work with. Here is where it goes to the pitch bend. And so we're going to put this in between here. So we receive our MIDI note here. And then we're going to put in a new subpatch right here. This will be for our tuning and detuning. And we're just going to call it PD space OSC_1_tuning. How about that? Now it's opened up, since we made a subpatch, it's opened up a window here. And we'll get to that in a moment. First of all, we need to put in our controls for this detuning. And we're going to use, once again, the number 2 box, meaning the second variety of number box. Looks like this. Let's make this useful for what we're going to do. We're going to go into its properties. And now this one is going to be for octave, so that you can detune your oscillators by octaves. And so I'm just going to put the label O there for octave. And we're going to have it be able to go detune down up to 4 octaves and up to 4, because you probably don't need any more than that. Okay, so that's why I changed the number range, so that it's something that would be useful, so people aren't going into thousands of octaves and doing things that wouldn't really work out right. And so it's send and receive symbols. We need to name OSC_1_, we'll just call it octave_send. And its corresponding receive will be OSC_1_octave_recv, the way I name things. Now its label, I'm going to hit apply down here. To fit in this space better, it's better if its label is just to the left of the object. So we need to move it a little bit left and down. And the way we can do that and I'm just doing this from experience. It's offset to the left. I'm going to make -7. Let's see how that works. And then it's Y offset. I'm going to need to make it in positive values, and I'm going to try 7 there as well. Hit apply, and let's see where it is. Okay, pretty good. I'm going to move it to the left a little bit more so it's not crashing into it. So its X offset will be -10 then instead of 7. Okay, apply that, and let's see how it looks. Sorry. Yeah, that's better. Okay. Now we're going to change its number of digits to be 1. Its width here is basically in digits, but it adds a little extra space than just 1 digit. Actually, no, 2, because you'll need 2 digits to display the negative values. When you detune it down an octave or 2, there'll be a negative sign there, so you need space for that to display. Okay, so now I'm going to press OK, and you'll see that our number box is now not as wide, but it's the width that we need it to be. So this is going to go here. Now I'm going to duplicate this just so I don't have to do the changing of the label position again, and put it right here. But we're going to change this. Instead of doing octaves, this is going to be for semitones. And I'll abbreviate that S. And we'll want its width to be 3. Because semitones is basically a shift that we want it to be able to go up 12 or down 12. So it's a 2-digit. Oh, I should make it it's a 3-digit number at most with the negative sign included for when you're going down. Because semitones, there's 12 semitones per octave. And this is where you can adjust those. Octave, I'm going to name it semitone. Send. And here, OSC_1_ instead of octave. I'm going to put semitone. Receive. Okay. That should do that. Now, and these are common in synthesizers to have this type of detuning. Another one that we're going to use, we'll duplicate this one. Another one that we're going to use is something that allows you to adjust by cents. CENTS. And what that stands for is dividing a given semitone. That means notes right next to one another, such as A440 is MIDI note 69. The next note up, MIDI note 70, is an A sharp or B flat. And so in that case, the cents are the divisions in between those two notes that are right next to each other into 100 different slices. Hence the term cents, like from century, meaning 100, or percentage, divisions of 100. So it really is dividing up the percentage distance between those two notes. So this will need to display 4 digits. And it's basically going to go from -99. Let's make it 3 digits. Sorry. -99 up to 99. Now, why not 100? Well, if you want to go 100 cents down, you're literally going to the next semitone down. So you would use the semitone adjustment here. The whole idea of doing cents is you're doing increments in between semitones. So you don't need to be able to go down 100 or up 100, just up to 99. because the other box can be used to adjust otherwise. We're going to put C here to abbreviate cents. In that case, I might as well change the semitone adjustment to 11 rather than 12. Because if you want to just go up or down an octave, you use the octave number box. So I'm actually going to change that. Because going up 12 semitones is literally going up an octave. There we go. So I changed those symbols to be cents for this box. And so does it fit in there? Pretty well. Here we go. Semitones. What I'm going to change here is its number range to -11 up to +11. I don't have to change anything else here. I just remembered that if you want to go up or down an octave, just use the octave displacement right here. Okay, so now we have these 3 boxes set up so that we can detune the oscillator. Now, we're going to take this new subpatch that we made and make some patching in it. It's going to have an inlet at the top. So I'm going to make an object in here called inlet. And it's going to have an outlet at the bottom. Just guesstimating right around here. So this is where, in between, we're going to have whatever MIDI notes coming in is going to undergo adjustments in this subpatch based on any of the settings you do here. And those adjustments will come before the pitch bend, where you can even bend it up and down more, and even before the frequency gets sent out. So whatever adjustments are made here using these boxes will be accounted for as the frequency that's currently being played when it goes out down the rest of the signal chain to the filter and to the FM modulation oscillator. Alrighty, so now we just need to put the guts of this in. And it's basically a little bit of math doing this, but not a lot. It's not heavy stuff. So we know that MIDI notes are coming in. Might as well make a number box so that in testing it out, we can see those numbers coming in. And then what we want to do is have the ability to adjust it by octaves. So this is where we're going to receive OSC _1 _octave _send. So when you make an octave adjustments, let me move this over. In this number box here, it will do them here. Now, what's going to happen is that number box's range starts at 0, which means nothing. It can go up 1, 2, 3, 4, or it can go down 1, 2, 3, 4, -1, 2, 3, 4. So what we want to do is have those multiplied by 12. Because literally in MIDI notes, which are the semitones in music basically, an octave is 12 semitones. So if you want to go up 1 octave, for example, you set this to 1. 1 comes in here times 12. And then what happens? You literally just add that to the note here. But remember, when we're using adders like this, anything coming into the right inlet will not change or will not be calculated unless the left inlet is banged or a new number comes in here. But since you may want to hold down a note and then change its tuning, in order to hear that tuning change, we'll have to put our good old friend, a trigger bang float, on this. So that way, if the MIDI note doesn't change, like you're holding down the key, and then you adjust the octave here, you will hear it actually change because the calculations will happen. So there we go. That's simple enough. That allows this to shift the pitch up and down octaves. Now semitones. Since it allows negative values coming through by using an adder here, anything plus a negative value is basically subtracting. So that's why an adder works. So anyway, what I was getting on to next, semitones. Receive OSC _1 _ semitone _send. And I'll put it right here. Basically, once again, this is going to be adding. We want an adder here. In this case, it's just simply going to be adding the value that comes out of here. But we do need that trigger bang float. So you can be holding down the MIDI note and hear it shift as you hold it down when you adjust the semitone values. Simples. Okay, next we have sense. Now, in the past, I used to do this in a much more complicated way, actually calculating the frequency values. But I've found since then, and this is not normally part of the MIDI protocol, but Pure Data uses this to interpret things. You can have, for example, MIDI note number 69, which is A440, 69.01, 02, 03, 04. You can have basically the space between 69 and 70, or 69 and 68, which is the note below, have a decimal point and then the numbers in cents that you want it to be detuned. So that is very convenient. So we can receive our OSC _1 _ cents_send here. Now the only thing we have to do is, since these are decimal points, we got to multiply them since it's coming out in whole numbers, because it's easier to adjust things in a number box if it's whole numbers. But here's where we're going to make the adjustment to multiply them by 0.01, which will make, for example, the number like 50 cents, halfway in between the note above or below. If you type in 50 here, it gets turned into 0.50 and then added to the number. Or it could be negative 0.50. So here, once again, we're just adding. We add our trigger bang float. Like that. Look this up here. And then we'll get our result. And what I'm going to do for now is put a number box in here so we can see what that result is before it goes out. So I'll move the outlet back up here. Alrighty. Now, what we can do to hear this is test it out now. I'm going to close this though and just use my ears to see if it's working. Okay, I'm going to play a note. All right, let's put this up an octave. There we go. How about down an octave? There we go. All right, let's put it back to where it was. Adjusting the octave by 0. Now semitones. Let's put it up one semitone. It didn't take the number, so let me type that again. Remember, you have to be in run mode to do this. There we go. That's up one semitone. Now let's put it down -1 semitone. There we go. And then put it back to, there we go. You can also click on these number boxes and drag up and down. Now this will be more powerful when we add our second oscillator and the rest of the objects so that we could hear them with one another. So we can basically create harmonies as well as chorusing. Now here, cents. This will take a little bit more to be able to hear. 1 cent shift may not sound like anything. So I'm going to type in 50. There we go. That did go up in pitch. Now let's type in -50. And back to 0. Alrighty, cool beans. It's working. Now, what we're going to do, since we want a duplicate of all these modules, I need to expand this down a bit so there's room for them. We could do this one of two ways. We could select all these, hit Control D or Command D in Mac to duplicate them, and drag the blue highlighted duplicates down, and then go through each one and rename them. But that could take a while. I'm going to show you a quicker way. But the first thing I'm going to do is double check to make sure everything in here is named appropriately. Like all the things that are from this object. Now, receiving MIDI note, that's fine. That doesn't need to change. There's still just going to be one MIDI note coming into both oscillators. But I want to make sure that everything has OSC_1 as part of its name. OSC_1_ and then the rest of the name. That's our freak out here. Our bend. Let's just check. I don't think there's anything else being received except from MIDI, which doesn't change. Your MIDI module, there's only one of them, so that doesn't need to change. So that's good. Let's check here. There's sends and receives on this wave shape. OSC_1_ Yep. I think I remember having in this wave table, OSC_1_ wave shape. I think I've already made sure in a previous video to name these so that there was OSC_1_ for the names of all the things in this module. Like I'm just glancing over the messages there, the output at the bottom, wave. Yep, everything has OSC_1_ as part of its name, table included, because none of these things there we go. Yep. Because the whole point is there's a way to rename all these in one fell swoop, so long as they're all named properly to begin with. That 1_ there, it looks like 2. Okay, no, it's fine. So it looks like our OSC_1 module is fine and is ready to go. Now I'm going to assume the other modules, it's the same thing. Well, no, let's not assume. Let's check. This is supposed to be FM_mod_1. Okay. Same thing with the frequency and yeah. Yep. Okie dokie. This is looking good up here because there's a signal coming from OSC_1_ over here. I'm just glancing through, making sure they have the _1_ in their names. Okay. Amp mod, same thing. Now, since these signals, I've tested this out and these signals are working, they've got to be named properly. But if you see any red things here saying no corresponding send or something like that, that means you have things labeled wrong. Yeah. Now, if you want to be truly careful, you should open up each of the objects and just see. Now, what about these toggles? Do I even have send and receive symbols on them? No, because yeah, they get turned on and off manually. They don't need to send or receive anything. Okay, good. Now, filter, I'm pretty sure is good. Let's just do a quick once through anyway. We will also be testing everything afterwards just to make sure. Remember, the MIDI stuff doesn't need to have an _1 or anything because there's only one MIDI module, and both oscillator sets will be using that. Yeah, all the stuff is looking good here. What about our ADSR? Especially these things up here. Did I name them properly? All right, here's our filter one out. MIDI doesn't need to have an _1, but ADSR _1 _. Yep. Okay, good. And then here is where we have our DAC for now. That is going to change. So I'm going to take the DAC out of here. And instead, I'm going to say send with a tilde because it's the audio signal. ADSR _1 _out. Because we're going to make another module to mix together our two signal chains. Okay, so this makes sense. This means this is the audio coming out of the ADSR module. Then I'm going to hit Control S. Now this is what I'm going to do. You literally can select all these, duplicate them, put them down here, and then go through and wherever you see an _1 _ rename it to _2 _. But there is a faster way, as long as you have a text editor that lets you edit text and save it to the same file name. I'm going to select this stuff and say Control C to copy. That's Command C in Mac. And I'm going to go up to this file menu, the file menu associated with our patch. In Mac, just make sure you click on the patch window, and then the menu bar at the top of your screen should be the menu bar for this patch window. So you go to File, and then you go to Open, or New, actually New. Now it's made a new patch window here, and I'm just going to paste these in. Control V. And I'm going to move them down because they're going to be further down in our display later. Like this. Okay, now I'm going to save this. And I'm going to save it to the same folder. The episode 11 here, this is my synth. This is the main patch, the one we're going to use. And this here, we're going to create a temporary file. PD files are really text files with a, you'll see it in a minute, a coded language in it. But what I need to do for Notepad or anything else, well, this isn't Notepad, this is PD. So I'm just going to type in the file name temp. This is just going to be a temporary file. And I'll save it there. But now let's close it. Now what we're going to do is here's the files on disk. So wherever you saved your temp file, you want to be able to open it. And there should be a way to do this in Mac too, where you have an open with option. what I want to do is open this with a text editor. In PC, it comes with a notepad. Here it's saying which Wish application. What the hell is that? But in PC, you can go to more apps here and see other apps in the list that might be able to open it. I want to use a simple text editor. In PC or Windows, that's Notepad. In Mac, I think there's something called Simple Text, or at least back in the day, there was a simple text editor called Simple Text in Mac. But I don't know if that's still there or not, but you want something that edits text, not a word processing software, because that'll add extra junk to it. Now, I've opened it up, and you see Notepad's opened up the PD file here. And look what we got. We got all this coded language that basically, this is telling PD what to put on the screen. This is what PD really is underneath that visual patching that we have on the screen. Now, what we can do, in Mac, there's probably a text editor that has the same abilities. You want to go to Find and Replace, or Replace, it's called in Notepad. And what we want to do is take every _1 underscore, change it to _2 underscore. Okay, you got to make sure you type those accurately. Then you say replace all. Now we can just simply save this by hitting Control S or Command S in Mac with whatever text editor you use. And then what you do, we're going to open up temp and we'll look at it real quick. Uh-oh, this patch name is still OSC1, but these are just names of the modules. But we probably do want to change those names. So let me see if it lets me alter that. The reason why I didn't change these is that I searched for _1 underscore. And that's what you want to do. Because in the coding language of PD, there shouldn't be anything other than our things that we named _1 underscore that uses that. But I'm just going to name these here differently so that they have different names too. These are just really labels for the names of these submodules. But look, all the table names are now _2 underscore. And let's open this up and look. You look over here, MIDI's coming in just fine, but we have OSC _2. So basically this whole chain of modules now are all using the label _2 underscore in the names. That's why I named things the way I did. So I could in one fell swoop do this. I'm going to copy it. Control C and then Control V to paste. Command C and Command V in Mac. There we go. We have our second copies here. Now the thing is, remember we disconnected our DAC. We're going to do a real temporary thing to test this out. We're going to R tilde ADSR _1 underscore out. And just so things don't distort, I'm going to cut its amplitude in half times 0.5. Sorry, that needs to be a star tilde. Did I make a tilde? No, I hit something else, I think. There we go. And that's going to, well, we're going to mix them together. I'm going to duplicate this real quick. Control D in PC, Command D in Mac to duplicate. And this is going to receive from here, this one. This is where this signal's ending up now. For this side, that'll be ADSR2 multiplied by 0.5. And then we're going to take these and send them to a DAC real quick. We are going to make one more module. It'll be very simple patching. And just so they don't come out just one side, I'm going to hook this up to both sides. I'm going to hook this up to both sides so we can test this out real quick. Now, I'm going to let oscillator 1 be a sine wave, just so we can hear oscillator 2 as something different. I go into run mode and change it to be a sawtooth. Now let's play a note. I don't see anything happening there. That means we need some fixing. Yeah, I can save that. I probably won't need that temp anymore, but let's see. Didn't see any errors here. Okay, let's close the patch. Save it, yes. And reopen it again. We're going to reopen the synth patch. What? Oh, I closed the file folder it was in. All right, well, I have it in documents. Go down to PD. We're in synthesis with pure data, series 1, episode 11. I'm going to open up the synth. Here we are. Now, everything's lighting up. It probably just needed for all the load bangs to happen that set the default values for all the modules. Let's just change the tone that this is. Now that kind of covers up the sound of this sine tone a bit. But let's see. Let's make them both sine tones. Take this one and make it an octave lower. Oh, that's 2 octaves lower. Hard for me to tell, but I am not sure I'm hearing this octave. So let's displace this by some semitones. Then we'll hear it for sure. Yeah, it's there. Let's go. And we're going to keep the octave displacement where this is an octave lower than the other. I'm going to make them both sawtooth waves. There, I hear them an octave apart. Now here's another thing you can do. We can displace them by cents. And this will be giving us chorusing. I'm going to make this one up 5 cents. And I'm going to make this one down 5 cents. And with them off by a little bit. You hear that? A nice expanded sound. It sounds cool. All right. So it's working. It's working. I mean, now you can do things where maybe have this have a quick attack to it. Let's make this one a square wave. And have a slower attack to it, so it comes in slower. So we're going to hear the sawtooth to start, and this will be slowly coming in. Well, not that slow, but. Yeah, I do hear it rising in at a delay. We make this a slower attack time. Yep, I hear it coming in. But now there's a whole bunch of possibilities. And I think in next week's thing, when we color things up, make things look nice, we'll be able to do that. Now we could take one of these and have it do frequency modulation while the other doesn't. We could change the filter on the one. Kind of getting sick of this. But now you have two independent oscillator chains to do different things. All right, let's finish this up. Now we're going to take this. Now, how tall are these? I'm going to right click on the background to see the properties. Their vertical size is 260. So two of them together will be 520. Plus, let's give a little extra space here. There's about 5 pixels. Let's say 525. So I'm going to make a new subpatch, PD mixer. And then here's the new window that came up with that. Right click on the background, graph on parent. And it's going to be, how wide do we want it? Well, this doesn't need to be wide at all. I'm going to make it 100. No, that's too much. Let's make it 50 pixels wide. And then 525. I'm going to hit apply. Now let's move this gray thing. Since we have the window open, it's gray. Put it here. Yeah, it fits about the width of them both. Okay, good. I'm going to press OK. This is going to be our mixer module where we can mix how much of one oscillator versus how much of the other oscillator. So what we're going to receive in, what we're going to do this is make a big old slider, a vertical slider. I think that's Command Shift D or Control Shift V in Windows. I hit C instead and made a canvas. There we go, vertical slider. Or you can just go to the Put menu and find it. How tall do we want this? Well, visually, let's make it 500 tall. And its range is going to be from 0 to 1. Its send symbol, now this we can name differently. We could just call it mixer because there's only going to be one. Mixer underscore send. Mixer underscore receive. I know we make a lot of receives that don't ever end up happening. It doesn't need a label because the module itself will have a label. Now I'm going to make a load bang. Just to begin with, it's good for your mixer to have a value. It automatically added it to the slider because that was the last thing I made. But just put this object box up here, load bang. We need to have a value in this mixer, begin with, that makes sense. It would be good when this opens, put it at 0.5. That means each side of the mixer or each oscillator will be equal. in strength, which is a good way to start. And then as you go, the user can adjust it by adjusting the mixer settings. So we hit this. There, the slider now has a value. All right, now what we're going to do is this. Receive tilde ADSR underscore 1 underscore out. Now that's receiving from this ADSR for this first oscillator signal chain. And the second one I'm going to type is going to be receiving from this ADSR from this signal chain. Receive ADSR underscore 2 underscore out. So this is where the audio signals from these are coming in. And down here, we're going to use amplifiers to control them. So what we want is whatever the top one is, we want the bottom one to be an inversion of it. Meaning, as we move this up, since we're moving it towards the top, visually, we're moving it up towards this signal chain. So that should be increasing the level of this this signal. So since this is 0 to 1, as you move it up, we're going to get more of the first oscillator. So we simply just put in a star tilde for that. And what it's going to be receiving, what it's going to be multiplied by to control that level, is the value of this slider as it is. So we'll make a receive here. Receive mixer underscore send. Now to make this smooth and not have snaps, those artifacts we try to avoid, we're going to use our old friend pack F50 and line tilde to smooth that out. So we hear more of this slide. We hear more of the top oscillator when you move the slider up. Now what we want is as you move the slider up, you hear less of this. And when you move the slider down, you hear more of this and less of this. So what we need to do is make it an inversion. Since we're going on the range of 0 to 1, that's easy to do. We've actually done that before for some things. Like in the amplitude modulation oscillator. So we're going to put a star tilde here. We're going to receive mixer underscore send. And now we want to invert it. So we're going to put it through a swap 1. Remember what this does? Means whatever comes through the right inlet or is the creation argument is going to come out the left outlet. Whatever comes in through the left inlet is going to come out the right outlet, which means we're always going to have 1 coming out of the left outlet. So that would be 1 minus whatever comes in through this left inlet. So we basically are saying 1 minus whatever this slider is. The inversion, in other words. Now we still need our old friends pack F50 and line tilde. And put that into the right inlet here. Okay. And then we take both of these signals and add them together with a plus tilde object, an adder that operates at the audio rate. And then This can simply go to the DAC. But since we don't want it just coming out the left side, we'll take the same signal, put it out the right. Okay, now I'm closing that window. I'm going to hit Control S to save. Now I'm going to hold, now just to hear the difference between these. Let's take their choruses off and make them basically both the same pitch. But this is going to be the sawtooth, and just so we can hear a very clear difference, we'll make this sine wave. Okay, so right now, I'm not hearing anything. Let me see if there's any errors in the PD window. Oh, I know what it is. Since we hooked that up, the mixer values never got sent through. So I just moved that, but kind of leave it in the center there. Now, as I move it up, I should hear more triangle. Oh, since this is a sine wave, I also want to turn off the filter. Move these all the way up. Yeah, I'm hearing more sawtooth. More sine wave down there. So now that's a mixer between the two different signals. So you can mix how much of one versus the other. Now let's chorus them. That's a good effect. I like it. 5. And let's put this one down an octave. Sines make good bass tones. Oh, actually, no, I made it a square, which actually is also a cool bass tone. So now if I want it to sound a little more bassy, I should mix it down more towards the second oscillator, which is down an octave. We still have our modulation effect here that controls the filters. And we have our pitch bend. So anyway, this is a pretty good, simple synthesizer employing the basics. I hope that you have enjoyed our series here. The 12th episode is just going to be coloring things up, making things look pretty. But we are now at a state where you've got a lot of the basics of synthesis down. And after that 12th episode, this first series will stop, and then series 2, I don't know, we'll see. Maybe you can leave comments to tell me what you'd like to do. Would you like to expand on this synthesizer or explore other concepts? I'm going to have to see what series 2 should be about, or learn synthesis with pure data. But anyway, please subscribe, like, show me some love. But in any case, that's it for today. Take care.